let's get into the top 10 here a little bit. I've put them in order from 10 to 1, with 1 being what I consider to be the most important. There's always room for discussion on the sequence, and I'm sure in some cases there's a few things I could probably put together a top 50 list, but we got to start somewhere. So we'll start with the top 10. Number 3, to keep us moving, build high-quality, accurate data. I've referred to this in a couple places. I'm going to talk about a handful of key things really quickly, but a lot of times what we find is that during the implementation, the organization doesn't want to undertake building that data. They look at it as too time-consuming, too costly. They kind of go with the concept of, well, we'll improve the data as we go. I can safely say, out of the hundreds of implementations that I've seen, I have never seen an organization build it as they go, unless they've really put a short-term plan in place to build it shortly after they implement. But typically it never gets done because people get ground down into their day-to-day work. So you've got to really think about this stuff. These are the things that make the system hum, that make the system work. The first two kind of go together. Location hierarchy. You really want to think this through properly. You want to have it detailed. You want to clearly define your processes and your systems. Your master equipment list. This is the core of the system. You want to have not just a shell record for your equipment, but you want to have detailed information available. So it's things like proper classification, subclasses assigned properly, attributes. I'll show you an example on another screen here in a second that are populated. Clear descriptions, standardization setup. All of the assets that you actually have in your plant are reflected appropriately and accurately in your system. I don't know how many places I've been into again where you go out and do a quick audit of their master equipment list that's in the system and what they've got on the floor, and it's pretty obvious it just doesn't match. There was no maintenance of the process. They didn't put details in when they initially set it up. This is the core of your system. It takes time, it takes effort, but it drives all the things you see on the second sub-bullet. This is the key in the heart of your reporting, your analysis, your cost tracking, failure tracking. You can read those as well as I can. If this isn't set up properly and in good detail, this is another place you might say don't take a shortcut. Build the detail, build the levels of the hierarchy out. It's going to help people find the right piece of equipment. You're going to record work against it, cost, etc. Get that done right. That's a key one. That's at the top of the list. I could almost put that pretty close to being up to number 1, but you'll see there's a couple others that are more important. Item master would be another example. Stock and non-stock records. I want the same type of thing, good detail to my parts records. I can show you many examples, and you've probably got these in your organizations, where I've got things like a description of bearing and maybe a part number. Well, that's great if I know the part number, but without any details on the bearing, I don't know what it goes to, what it is, what else I can use it for. Neither do your maintenance folks, your planners, your craftsmen, your supervisors. So whether it's trying to support a breakdown or a planned job, that's almost useless information. You've got to build it, you've got to go get that information, and you want to use the functionality in these tools to properly describe it. Then that feeds into things like bill of materials. Build these. That's the link between the items and your equipment. This is key to increasing planner productivity. If your planner constantly has to go figure out from among tens to hundreds of thousands of parts in your system, which one is the right part, which bearing is the right one for that particular motor, as opposed to going to a bill of material for that motor and saying, here's my inboard bearing for that motor, you're wasting a huge amount of time, and you're probably also making a lot of errors. So when you do go to do that job that the planners looked at, they've selected the wrong bearing. So I start to do the repair, and guess what? I can't finish it. There's a huge snowball effect here. So bill of materials are a great productivity tool. They take a little work to build, but if you've done the other things like master equipment list development, where I've clearly identified my manufacturer and my model numbers in the system, I can build bill of materials that cover many different components, particularly if your processes and tools have a lot of common equipment. So when I identify a Gould's pump XYZ, I can now create a bill of material for that Gould's pump, and I can apply that bill of material anywhere I have that Gould's pump. But in order to do that, I have to have clearly called out the manufacturer and the model number of that Gould's pump in my system so I can query those records and assign the bill of material. So hopefully you're following me on that one. Failure hierarchies would be another example. We want those to be driven by class and subclass, some sort of a problem cause remedy structure. So when I do failure codes, I'm not picking from the same list. So in other words, the failure codes that I use for a pump are very different than what I might use for a tank or what I might use for a gearbox. You can build these, and if you're using some proactive techniques like RCM and failure modes and effects analysis to develop your maintenance strategies, these are a natural offshoot. The other thing you can do is, we, for example, sell a failure hierarchy library that are driven by the class and subclass of assets that you can actually buy and load into your tools. It's a great starting point because it gives you a much more detailed description of the failure situation than simply having a standard list for every type of asset that you have out there. So again, day one, if you're even looking at implementation and you don't have a major effort to enhance and build your data, and if your implementation says, well, we're going to take the data we've got and we'll restructure it so we can jam it into our new system, I would seriously reconsider looking at that. Because basically what you're going to have in your new system is what you got in your old system. If you've got an existing system where you haven't done this work, I would seriously consider putting an effort into doing this, and you'll find you've revved up your system consider a number of levels by having good foundational data. I said I'd give you a couple of good examples. This is one of what you might find in an asset record. What you're looking at, it's a little hard to read on the screen here, but this is an eMaint screenshot. So things like having the proper classification on the top right, you see a class and a subclass, of a class being motor, a subclass being an AC motor. There's multiple subclasses associated that you could be putting in here. A good description that's consistently driven. In this case, you see that we're using a standard here that has technical information that's derived from what you see on the bottom from the nameplate information. So the attribute template, which is the list of fields on the bottom left for an AC motor, for example, the attributes are horsepower, RPM, voltage, amperage. You can read that list. But actually having the value in the data record and using that to actually build your descriptions is very valuable. So now when I look at doing PMs, for example, for an AC motor, you can see up in the middle of the screen, I've got the manufacturer, I've got the model number and serial number. I can now start to assign and put those types of things out there, the PMs, the bill of materials, the job plans. I can link those to this particular motor, a Dayton, I can't read the number there, Dayton, what is it, 2M191. I now have that information, and it helps me leverage the other information that I'm building in the system. So this is the type of data I'm not talking about that you would build and populate, but it takes time. You've got to go out and get it. You probably have to go out to your equipment and actually get this information off of your nameplate. But it's extremely valuable. You need to look at building this type of data. This is just, I should have pulled this up. This is a close-up of that attribute template. I'll leave it up on the screen just for a second. Those templates, if you don't have them, you can build them yourself. Again, I'll also say that there's a number of places you can get them, but MRG, for example, has pretty much all of these templates built out for almost any class and subclass of asset that you would find. So you can buy these. You don't have to build them from scratch. The data you may have to populate based on the equipment you have in your plant, but the template itself and the values that go into those fields can be bought. The next screen is an example of an item record. Same kind of concept, but this is valuable information to a number of people. It's valuable to your people that are trying to buy the parts, to your vendors when you place an order, but probably even more importantly, it's very valuable to your planners, to your reliability engineers, when they start looking at things like, am I, the parts that I'm using, am I having problems with a particular type of part, a particular manufacturer's part? Am I using more of those? I can make the same statements for the assets. If I don't have this information in here, I can't slice and dice this. I can't see, how many times am I replacing or using a certain manufacturer and model number of motor. I can't see how many times that has failed or I've used it as a replacement part. I can't leverage that for, maybe corporate purchasing to go out and say, hey, Baldor, we're using X amount of your motors across our corporation. We want to look at, pricing deals here. So lots of pieces that you can work on here. The last example is a failure hierarchy. Again, a little bit busy, but if you kind of follow, let's look at the right side here for a moment. If you look on the very right hand of every line, it says whether it's a problem, a cause, or a remedy. And you can see there's a little bit of a hierarchy here. If you look about 7 lines down on the right-hand side, it says the problem would be, an example for an axial pump, is that the impeller becomes loose, could be a potential problem. Well, you've got a number of causes of that, and if you kind of skip through, the next one down would be that I could have had some sort of degradation of the impeller hardware or the key. If you skip down 3 lines, you then see another potential cause would be that there was corrosion. The next one down is incorrect installation of the impeller. Underneath the first cause, let's just go back up a little bit, under degradation of the impeller hardware or key, some of the remedies could have been that I replaced the hardware, I replaced the impeller itself, or I replaced the pump. The idea here would be these are, they view a little differently in the systems. You typically, when I pick the cause, it only shows me the remedies that are associated with that cause, for example. So I'm picking from relatively short lists. But if I can actually complete these for the work orders that I close, that's huge information from a standpoint of my reliability program and things like problem elimination and root cause failure analysis. Now I've got real information that I can act on. So I'd strongly suggest looking at that failure hierarchy structure and using that within your system. Again, these types of things can be pre-purchased. You don't have to build these hierarchies yourself. You found this interesting, some helpful points and comments, and if anybody's got any questions, I'd be happy to answer them.